The first two are the M830, High Explosive Anti-Tank, or HE, round, and the M830A1, Multi-Purpose Anti-Tank, or MPAT, round. The SEP-V4 variant, slated to being testing in 2021, will also include new laser rangefinder technology, color cameras, integrated onboard networks, new slip rings, advanced meteorological sensors, ammunition data links and laser warning receivers. However, although Army developers often maintain that while the latest, upgraded high-tech V4 Abrams is much more advanced than the first Abrams tanks produced decades ago, there are limits to how much the existing Abrams platform can be upgraded. A lighter weight, more high-tech tank will allow for greater mobility in the future, including an ability to deploy more quickly, handle extremely rigorous terrain, integrate new weapons, cross bridges inaccessible to current Abrams tanks and maximize onboard networking along with new size, weight and power configurations. The idea is to engineer a tank that is not only much more advanced than the Abrams in terms of sensors, networking technology, force tracking systems, an ability to control nearby drones and vastly increased firepower, but to build a vehicle with open architecture such that it can quickly accommodate new technologies as they emerge. For instance, Abrams was first fielded with a 105mm cannon, yet built with a mind to potential future upgrades such that it could be configured to fire a 120mm gun. The new tank will be specifically engineered with additional space for automotive systems, people, and ammunition. As computer algorithms rapidly advance to allow for greater levels of autonomy, the Abrams tank will be able to control nearby drones using its own onboard command and control networking. Unmanned wingman-type drones could fortify attacking ground forces by firing weapons, testing enemy defenses, carrying supplies, or performing forward reconnaissance and reconnaissance missions while manned crews remain back at safer distances. Active protection systems are another instance of emerging technologies which will go on the latest state-of-the-art Abrams tanks and also quite likely be used for the new tank. Using computer algorithms, fire control technology, sensors, and an interceptor of some kind, active protection systems are engineered to detect, track and destroy incoming enemy fire in a matter of milliseconds. The Army is currently fast-tracking an effort to explore a number of different APS systems for the Abrams. General Dynamics Land Systems is, as part of the effort, using its own innovation to engineer an APS system which is not a bolt-on type of applique but something integrated more fully into the tank itself. The use of space in the new vehicle, drawing upon a better allocation of size, weight and electrical power will enable the new tank to accommodate better weapons, be more fuel efficient and provide greater protection to the crew. While advanced Abrams tanks will be using a mobile auxiliary power unit to bring more onboard electrical power to the platform for increased targeting, command and control technologies and weapon support, mobile power is needed to sustain future systems such as laser weapons. The Army cancelled its plans for a future ground combat vehicle, largely for budget reasons. Some of the innovations, technologies, and weapons systems are informing this effort to engineer a new tank for the future. Design specs, engineering, weapons, and other innovations envisioned for the GCV are now being analyzed for the new tank. In particular, the new tank may use an emerging 30mm cannon weapon planned for the GCV, the ATK-built XM813. The XM813, according to Army developmental papers, is able to fire both armor-piercing rounds and air-burst rounds which detonate in the air in proximity to an enemy in defilade, hiding behind a rock or tree, for example. The computer-controlled and electronically driven weapon can fire up to 200 rounds per minute, uses a dual recoil firing system and a semi-closed bolt firing mode. The new tank may quite likely use a futuristic, lightweight 120mm cannon first developed years ago for the Army's now cancelled Future Combat Systems, or FCS. FCS worked on a series of leap-ahead technologies which, in many instances, continue to inform current Army modernization efforts. The FCS program developed next-generation sensors, networking, robots and a series of mobile, high-tech 27-ton manned ground vehicles, or MGVs. The MGBs included a non-line-of-sight artillery variant, reconnaissance and surveillance, infantry, medical, and command and control variants, among others. One of the key vehicles in this planned future fleet was the Mounted Combat System, or MCS. The overall MGB effort was cancelled by former Defense Secretary Robert Gates in 2009 because Gates felt that the 27-ton common chassis was not sufficiently survivable enough in a modern IED-built threat environment. Although the MGBs were engineered with a so-called survivability onion of networked sensors and active protection systems to identify and destroy approaching enemy fire at great distances, many critics of MCS felt that the vehicles were not sufficient to withstand a wide range of enemy attacks should incoming fire penetrate sensors or hit targets in the event that the sensor malfunctioned or were jammed. The Army's MCS program developed and test-fired a super lightweight 120mm cannon, called the XM360, able to fire existing and emerging next-generation tank rounds. The lightweight weapon being developed for the MCS was 2 tons, roughly one-half the weight of the existing Abrams 120mm cannon. The MCS was to have had a crew of 2, a .50 caliber machine gun, and a 40mm automatic grenade launcher. In fact, the Army's recent combat vehicle modernization strategy specifically mentions the value of adapting the XM360 for future use. Next generation large caliber cannon technology. The XM360 next generation 120mm tank cannon integrated with the AAHS will provide the M1 Abrams a capability to fire the next generation of high energy and smart tank ammunition at beyond line of sight,